software engineering, when we are discussing about the system design, in the beginning, there are few expectations from the user which are of non-functional type, right? So can you tell me briefly what is non-functional, what is functional? Can you tell me how do you identify that this is a non-functional requirement in the system and this is functional requirement in the system, and who is going to dictate all these requirements? Just tell me briefly, because it is very important when we are talking about such system design. Just tell me. I hope I'm audible.
So basically, it's the function of designer who basically divides task into functional or non-functional. According to me, I don't know if I am right, but functional is nothing but which is essential for the functioning of the whole system. Non-functional is nothing but the tasks which enhance the functions, but is optional.
Yeah, right. So partially it is highlighting or it is indicating those some important points. Any other student? Because you must have gone through 3-4 courses during your bachelor's where we work upon these two elements. In some courses we are talking about or focusing upon the functional part, implementation, functional part, uh, designing, and in some courses you must have worked upon some experiments, worked upon some exercise where your focus is on non-functional aspect. Just tell me briefly. That's why it is important to know how much sure you're about functional and non-functional, because as a computer science student you should be having this clarity.
सर बेसिकली नॉन फंक्शनल मेरे अकॉर्डिंग हो सकता है कि जो हम कोई ऐप बनाते हैं तो उसका जो ओवरव्यू होता है लुक वाइज वो एक नॉन फंक्शनल में आएगा, और जो उसकी एल्गोरिथम एंड कॉम्प्लेक्सिटी वगैरह जो टाइम स्पीड उसकी क्या है वो फंक्शनल.
Yeah, so I'm not asking about the elements which are coming under functional aspect and what others are coming under non-functional. I'm not asking about the elements. I'm asking about what do you understand. So can you tell me your definition of functional and non-functional requirement of a system? That's what I'm asking. Yeah, your elements are correct, but I'm asking about the definition. What do you think about a non-functional requirement or maybe functional requirement? Any other student? Say something.
द फंक्शनल रिक्वायरमेंट वो होती है जो अगर हम कोई सिस्टम डिजाइन कर रहे हैं और यूजर ने हमसे कुछ मांगा है तो दैट आर द फंक्शनल रिक्वायरमेंट कि हम वो तो फुलफिल करेंगे. रादर देन दैट नॉन फंक्शनल रिक्वायरमेंट्स वो हो गए लाइक अगर हम उसे कुछ पोर्टेबिलिटी अपनी तरफ से प्रोवाइड कर रहे हैं, कुछ एक्स्ट्रा सिक्योरिटीज हम अपनी तरफ से प्रोवाइड कर रहे हैं, दैट आर द नॉन फंक्शनल.
Okay, we are getting towards a correct answer basically. Not correct, but most of precise. Okay, any other student? Should I call names? Because there might be some students who are sleeping actually. I mean, that is what is the perception. And this is what we are observing in the BTech classes, that few students are sleeping, some of them are roaming, I mean, once they connected the class, after that they move from here to there. They are not responding. So in that case, what we do, we remove them from the class and ask them to not join the class for the next 2-3 days. So don't push me to do that, right? Because it is bad actually. When we have only 27 students, not having few students in the class is a bad idea. So be responsive, right? Don't push me to do that, because I can go to that extent also. I'm very bad among the students when it comes to following them. Last year it was happened with your seniors only. I have removed 2-3 students from the class because they're not responding. They're not at least saying anything. So we have removed them from the class. That's one part. Secondly, we have contacted their parents. Right? So don't push me to do that, because when I'm here for discussion, you need to respond, right? That's what we observe in the physical classes also. And this is what we are raising. These questions are related to some of the basic questions which you might have discussed during your bachelor's, right? I mean, that's what. So you need to respond with some answer at least. I mean, it should not be like I'm raising the same question again and again to you to start the discussion. That is bad part. Okay, so let's not go into that part because we will lose our day otherwise. But from the next class, I'm not expecting this behavior, right? You're not responding to the question. I mean, silently listening, not silently. You are in the dead blank position. Not getting any response from your side is bad idea. It is not encouraging, at least, right? So if you talk about the functional aspect or functional requirement of the system, and if you also discuss about non-functional aspect of the system. So functional aspect is something that is coming from the requirement from the client side naturally. So wherever we are having a presence of client, it is obviously that all the functional requirement will be conveyed by the client. These requirements will be coming from some business area, some business domain, and these are basically the task which system should be delivering. I'm saying task which system should be delivering, right? But there are few requirements which are not directly coming from the client. These are not related to the functional, the core activity, core task of the system. But there are few set of requirements which are assumed to be delivered by the system, right? So like one of the important non-functional aspect of any system is efficiency. So it is implicit, right? So whenever a client is saying that, okay, can you design a software for me? Can you design a system for me? Can you design a net banking system? Can you design a online ticket booking system? So in most of the cases, client is or customer is very sure of these requirements, right? So these requirements are talking about the system delivery, system performance delivery, right? And efficiency is one of them. One of the first thing which we expect as a user, right? That system should be efficiently delivering all these tasks. So basically, non-functional requirements are the set of requirements expected to be delivered on the functional requirements, right? So if your system is online ticket booking system, it should be efficient, obviously. So you are delivering a ticket booking task and it is efficient. It should be efficient. It should have some throughput. Like it should book maybe 7,000 tickets maybe per minute, something like that, right? So that is throughput. So there are many, I mean, if you talk about a standard set of non-functional requirement for any kind of software system, any kind of application, there are 28 non-functional requirements, and efficiency is the first one, right? Because now you are started working upon your project part, so you should always think of these requirements, these non-functional requirements, right? And in your engineering days, when you have gone through a course called data structure, each data structure related algorithm, like it could be a sorting, it could be any algorithm, there we observe, there we evaluate the algorithm based on these non-functional aspects. How much time complexity, how much space complexity, how much there is a complexity related to number of mathematical operations. I'm just not able to recall. So there we observe these non-functional aspects, maybe of algorithm, maybe of system, right? So there are 28 or 29 non-functional requirements which are to be evaluated based on the need, right? Because for a client, for a customer, it is not feasible, not possible to mention that, okay, a client is never be a position where he can say that along with these functional requirements, you need to provide these non-functional also, because client is a real world person. He is not having that idea, right? In some cases where client is aware, client is having some experience, he may dictate and say, all along with these functional requirements in the system, you need to provide at least this level of throughput. Like in the case of IRCTC, when they have revamped this system, maybe I think 2000 maybe 15 or 16 or maybe early that, they have revised this entire interface, and then the operation has been revised, system has been segmented. So on that that particular phase, Government of India has collected some observations. Not Government of India, the Indian Railways has collected their few requirements, few expectations from the user, and they have dictated that, okay, this IRCT system should generate these many tickets, at least these many tickets per hour, right? So that system is smoothly functional. And particularly if you observe this IRCT system behavior during this Tatkal window time, 10 to 12, something like that, that system is more efficient. System is generating tickets with higher throughput and with you can say the higher traffic time actually. So there we need system to be very robust, right? It should be more reliable. So when we say robustness is again a non-functional property, which basically verifies the system performance on exhaustive extreme performance condition. So between this Tatkal window, IRCT system is having some throughput check, because there is a heavy traffic. System should respond to each and every user. It should be equally available for each and every user. It should be pushing the data and publishing the data on the same time for both ends. Right? So there are these conditions where system has been checked, system has been verified, right? So there are many non-functional requirements. These requirements are not coming from the user, but they are being expected. Not all 28, but only 5, 6, or 7 are to be there, right? It depends on the system nature, right? Some cases efficiency is not that important. Some cases it is the throughput which is important. Some cases it is the reliability which is important, right? So like in the most of the real-time systems are the systems which are operating on the temporally dependent data, like transactions. We are performing transaction by using any gateway or any payment related platforms. These operations are real-time. There we need robustness, right? So there are many requirements, and when we are talking about such system, what do you think? What could be the first non-functional requirement we are expecting from the system? What do you think? Just tell me. Anything which you observe that could be the most important non-functional requirement? Anyone?
Efficiency.
Performance.
Efficiency, okay. What else? Any other answer?
Reliability.
Reliability, okay. Okay, any other observation?
Response, scalability,
Security.
recoverability,
Yes,
data
security. Some are
integrity.
saying security, some are saying responsiveness. Yeah. So there are many, but eventually, why we are talking about non-functional aspect of such system? Because in basically each such system or such system platform, user is basically located, right? For each operation of the system, user is located. So then it will become important, right? Because you have to respond to the user queries. And if you are not able to engage with user with real-time or realistic results, user will be going to a different platform. You will be losing the system usability, right? Such system usability. Now, usability is again non-functional requirement. So if your system is not responding to the user queries within time, it will be bad experience for the user, and user will be deviating from the platform. That's one thing, right? So there are many reasons for it, and there is another implicit non-functional requirement, that is accuracy. So if your system is responding to the user within a very fraction of time or fraction of unit time, but if system is failing to generate so-called relevant, so-called related results, then also user will be moving to a different platform, right? So these are the many, basically you can say non-functional aspects in a system which are important, and those are important to be ensured, right? So whenever we are discussing a design aspect, like you are also going to start working upon your project and then dissertation, their evaluation is one of the important aspects of system design. So today we will discuss the different components, their interaction, and maybe in the last part we will talk about something related to these design challenges, design issues, right? So naturally, when we talk about design issue of a system, it is with respect to the performance part, that how you are going to evaluate whether we have achieved a good system, whether we have placed all these components in a structure arrangement to deliver, to generate, or to ensure some level of expected performance for the functional requirement set, right? So I think this is visible perfectly, this size of image. Now, what we are saying in the beginning, because it is a fact and it is basically a philosophy now, because we are saying a such system is one of the application. Such system is one of the key application of IR, or information retrieval process, right? So don't be confused with the analogy. You cannot say that retrieval system is equivalent to the search system or vice versa, right? Retrieval is one of the sub process required in the search system or search engine, if you say, right? Retrieval is one of the sub process, important maybe, but it is one of the sub process within search system. And why we are saying, so after observing the different components, you can also be convinced with this statement. Now, if you see the different components in the search system and their interaction between these components. So these interactions are carefully placed here. You can see. Now, what are the different components we are observing? Typically in any search system. So these components are drawn or placed for a basic or maybe naive kind of understanding, based on naive kind of understanding, where we have just outlined different processing module, processing blocks or computing blocks, or maybe blocks itself that could be possible in a search system. So if you see the system from front side, like left side, where we have placed the search context, needs, or maybe knowledge. So this is what a requirement space, or maybe your list of things which you are going to search in the search system, right? So I mean, we are in the left side of the system, we are placing a user, where user might be having some inputs, some task, some questions, something to be searched on the system, right? And naturally, system user will be interacting with the system using interface. That's the left hand side position. So the first line indicates, first dash line, vertical dash line indicates a kind of boundary between the real world situation and the system, right here. So for this vertical line shows a separation between the real world and with the internal world of the system, right here. Now what we are saying, so in the back, so if you see the rightmost portion, here we have placed the set of documents, and these documents are basically existing in the internet world naturally, right? Because from there your search system will be gathering all the possible documents to its repository, to its store, right? So these are the two extremes. One side we are having input documents or maybe set of documents existing, located, stored, or maybe tagged, or maybe shared on the internet. So that is important. So these are documents which we are targeting to store in the beginning of the system, or maybe continuously storing from the internet. These should be available on the internet. That is the essential condition, right? So in the left side we have user presence. Their user is basically having their interaction with the GUI. There might be some search option provided where user will be submitting his query or his keywords or his term, anything you can assume, right? And the right side, it is the system responsibility. System means the search system which we are intending to design. right? So it is the responsibility of system to identify these documents from the internet. And naturally your system cannot explore or extract all the documents. You should be having some mechanism, some criteria to select the document, right? So if I say I'm interested to fetch the email ID of different individuals, right? So it does not mean you are going to extract the email IDs from the globally available documents. I mean, you cannot have that kind of approach whenever you're designing a system. You should be having some criteria. You should be having some reason to extract the document. Like if I ask you to fetch the email IDs, or maybe fetch the photos, or maybe fetch the documents related to certain area. So if you go for fetching the names of faculties from all the NITs, all the IITs, all the technical institute in the India, that is okay. It is feasible, and it is also having some relevance. So in the beginning itself, you should think of these criteria that, okay, my system, my search system will be there to serve some purpose. And for that purpose, on the basis of that purpose, you are going to extract the document from the internet, right? I mean, if you are interested to design a search system which is equivalent to Google, in that case, you can open to explore, open to extract all the documents on your server. That's okay. But if you're designing a system for confined requirement, small set of requirement, you should be having a precise text acquisition algorithm here. The very first computing block in the system is text acquisition. So there we define a program called crawler, maybe text extractor, right? There are many programs, there are many tools or algorithms which are placed here in the text acquisition block to identify the relevant document from the internet, right? And based on that only, we are going to have our own repository to serve the user requirement, user request, user query. So you can assume how critical this task is. You can assume how critical or how important this algorithm is for the overall acceptance of our search system, right? And you can also write a basic crawler program, right, to extract. So sometimes it is crawler, sometimes people are saying it is a API also. I mean, if you are interested to extract the tweets from the Twitter platform, you need to design API sometimes. Sometimes these websites are also providing some platform from there you can extract the data, and that is called API. You might have better idea about API. So in a very theoretical way, if you understand it, it is the component, this text acquisition is a component which is there to identify, there are two tasks, to identify the source object, source file, source document from the internet, which can be useful for our system, our future system delivery, right? So we will be discussing about these many components in upcoming classes. Today we are trying to have a brief idea about their importance, their possible objectives in the system boundary, right? So naturally, after getting to all these documents which are relevant for our system delivery, right, the next task is, so whatever documents we have extracted here by text acquisition will be kept in document data store. So all the documents, because eventually your text acquisition will identify a certain document, maybe a PDF file, maybe a website, maybe a blog, maybe a video, maybe an image, anything, whatever you have identified as important. A meta file will be maintained in the data document store. You cannot store that PDF file on your source, right? Because that will create some sort of copyright violation in some cases. There are many issues we are facing, data sharing issues. So we cannot keep that PDF file, that image, that video in your document data store. In the data document or document data store, whatever you say, will keep all the meta information, metadata about particular file, particular object which has been identified relevant by text acquisition block. Parallelly, basically, we are sending these meta information, meta details to the next block, which is called text transformation. Now, suppose there is a PDF file and you have extracted the title, maybe it's abstract content, right? Or maybe keywords based on the text acquisition algorithm. So all these 3-4 fields will be sent to text transformation block. And there we will perform all kind of pre-processing on text data, because right now we are dealing with text data, right? That title and the keyword, then abstract. So primarily you are having text data. So if your text acquisition block has extracted text document, video document, or audio, or maybe a web page, so you should have multiple text processing algorithm here for each and every object type. So the importance of this text transformation block is to process, prepare the received meta information of different modality, because in one instance you could have text details, for second object we could have image related metadata, right? So for these different modality of data, we could have different metadata received, and then we have to process these different metadata by using suitable text transformation block and identify or prepare a set of important, set of potential maybe keywords, maybe terms which can be stored, which can be called as indexes. So in the index database here in the bottom, in the index database or in the index corpus, you could have all these index terms stored in the database. So if you see the right hand side of portion of the system, we need at least 2 storage entities. One is document data store, where we are keeping all the metadata without any processing, and on the same detail we have sent all the details here directly to store, and we have sent all the same details to text transformation, and further it goes to indexing program or indexing algorithm. There we have refined the set of index terms and stored into the index data. So this storage is important, right? So this is where, when in the previous class, study class, we have talked about one of the important aspect of any such system, that is how do you store this index data, because each and every such system is based on a storage, based on a representation model, right? So in the search system, it is the indexing program, it is the indexing approach which basically defines the way we store these terms into the index database. And then because your search system performance will be entirely based on the terms based stored here, right? So you must have heard about different representation approach. Like one of the key terms which students are nowadays coining, there is a model called word-to-vec, right? So word-to-vec is nothing, it is a model which gives you an idea that how to store these index terms, right? So different search systems are based on different data model. So you must have this idea that in the database course also you have this term called data model. So each database system is based on some data model, and data model defines the approach for storing the data, approach of representing the data to the user, both. So you can say, or you can assume how important it is, the notion of data model, right? So indexing algorithm basically gives you the possible terms which could be useful, right? So suppose you have extracted the detail about country, detail about its capital, its cities. There are many details, and you could have different algorithm here for different data model, and then you can decide approach that how I'm going to store these index terms into the index database. So this is the portion, indexing approach and index database. This is the portion of search system where you can say each and every search system is different. Like for, if you take the names of different search systems, maybe it is a Google, maybe it is any search system, this is the portion which is having most important novelty, you can say, because it defines the overall accuracy, overall delivery, overall throughput, overall relevance of the results of a overall system, right? Because you can see the index database is used to perform matching for a user query, right? So that's the relevance actually. So once you receive some sort of matching for user query, you can retrieve the other details about, because in the index data we will have only keywords, terms, right? Maybe related to a document. So that we will be maintaining, but eventually in the index database, we are going to have keywords. In the different data model, you can say we will have indexes with their co-located terms, indexes along with their something like other details, right? So it depends on the indexing approach, that how you are going to store the details about a term. But in the index database, we are going to have only keywords. That's what, right? So we have done with this right hand side block, and this entire block is called index part of the system, indexing part of the system, right? So this dashed line, right side dashed line, indicates a separation, right? So this is called backend part of the system, you can see, backend part of the system. So it is again having three levels, like we have in the case of database, where there is a three layer. On the top it is user or maybe external layer, then we have in between conceptual and logical, and in bottom we have physical elements. Similarly, in the search system also we have three portion of our system. Like in the rightmost portion, you can see different elements which are preparing the data for serving the user request, and then we have user placed on the leftmost portion where user is existing. There user will be posing some query to the interface. So I hope these different basic objectives of these blocks are now confirmed to you. Now we are proceeding to so once we are ready with index database and ready with obviously the document data store, now we are ready with all the possible things which could be used for delivering the system performance to the user query. Now let's go back to again the left side portion where user is pushing his queries, right? So now obviously if system is ready for performance, ready with all these functional requirement related data, we can go back to the user and say, okay, now can you submit the query? So obvious positions are there. User will be submitting his query. It may be a simple keyword query. So it is the designer understanding that what kind of interface we are going to provide, right? So like in the case of the obvious Google search system, we have a simple query box. You type a query, you submit it, and system will take that query as your input to process, to retrieve the documents results for you, right? So let's take one simple instance. So once user is basically ready with his query, he will submit the query on the interface. The very first thing is that within the system, the query will be sent to a evaluation component. So evaluation component will simply see the correctness of query. So it could be checking the correctness of keywords that user have submitted. So you can assume the basic thing is the correction. So if user has typed incorrect query term, you need to rectify it. You need to suggest a correction, something like that. So whatever correction we are getting nowadays in the Google search system, it is based on this evaluation system. This evaluation system is directly interacting with the user on the GUI, on the interface. There it is suggesting some corrections, right? There are many tasks, there are many things which you can place on this evaluation system. All the query suggestions which we are having nowadays, all the query completion, query suggestion, query completion, there are many things which are related to query formulation. So you can place any algorithm to achieve better performance in the evaluation component. So evaluation component utilize some details. Naturally, if you are targeting to achieve some sort of query suggestion performance in this here, you will be placing some algorithm here in the evaluation system, and naturally to perform that task, your evaluation, that algorithm in the evaluation component will be interacting with either this data, log data, meta store, or maybe sometimes it is interacting with the index data. In some cases, it is interacting with the document data store. So it is up to your algorithm. I mean, we have not drawn that interaction here because it is optional. It is up to the designer point of view that what kind of technique you are interested to implement. But in a very basic system, we are placing an evaluation system, and this evaluation system will simply perform something on the user query. That one instance we have said, the query correction is one of the tiniest tasks you can have, right? By having some sort of interaction with the dictionary, something like that. You can place a dictionary kind of connection algorithm, and then which can be helpful for correcting the user query, right? So once you assume that okay, user query is perfectly correct, there is no need to correct it. Let's keep this query as a question, as an input, and let's process it. So in that case, so query is here into the evaluation system, and evaluation system will simply save that query, store that user query into a store called log data, or maybe sometimes it is called query log, sometimes it is called anything. It is log. Basically, we are keeping all the records of the queries, right? So that's default storage in the basically in this middle view or middle layer of the system. We are having only one storage entity, right? Now, typically, evaluation system stores the user query. That's one obviously task, and the second task is to forward this user query to a component which is called ranking. So ranking system or ranking component will simply interact with, I'm saying interact with matching component to perform the matching. So actually these two components are usually placed on or existing on a single module. But here, just for clarity point of view, we have placed these two components in two different positions, two different blocks. One is ranking, another is matching. Right? So obviously evaluation system will send this query, forward this query to ranking module, and then in the very first iteration, ranking system will forward the query to matching. And it is the matching component, matching algorithm, which identifies all the possible relevant results for user query. So you can define here in the matching block, you can define a similarity approach. You can define there could be many approaches to define the matching. It could be a similarity mechanism. It could be a, there are a number of ways to define the matching between two documents, right? So you have these n number of options to be defined here. Naturally, based on the scenario, you will be defining a criteria, right? I'm saying a criteria. You cannot have multiple criteria. You cannot plug 3-4 similarity measures into one, because that will not deliver a purpose. You should be placing one component, one matching mechanism between user query and indexed terms. So matching will be performed in the very first between user query term with the index terms, right? And for those respective matched index term, the respective document details will be fetched from data document store. So whatever we are getting in the response of query in the Google search, these details like the title, there some of the internal details we are getting, it is directly fetched from the data document store, a document data store. From here, it is retrieved in the sub-step. The first step in the matching block, first step is to perform a match between user query and the document index term, right? So in the first term, it is going to interact with the term, and then the second sub-step in the matching block will fetch all the respective documents, and then it is basically forwarded to ranking module. Now the role of ranking model is significant because ranking model basically reorders or arrange the results in some expected order, right? So you cannot have ad hoc mechanism for that. You should have a criteria. So like in a basic set, you can arrange them based on some scores, right? And in some cases, suppose you have received 100 documents for user query, and you have defined some criteria. You means the search system has some default ranking mechanism, some default ranking criteria. So initially you can place or you can use that criteria to rearrange the results, right? Because why ranking is important? Because in the search system, we are having this assumption that whatever results we have fetched, they are not based on complete matching. That's one observation, one assumption. Second, if your system is based on exact matching also, so suppose it is based on exact matching mechanism and we have retrieved only 20 documents or 30 documents, on those situations also you should provide a mechanism to order them, because whenever you are pushing these results to the user, you should place them in a certain preference based defined order. So for any kind of search system, for any kind of search engine or retrieval process, you should have a ranking components, ranking algorithm arranged here, right? So nowadays we are having different software platform, different systems where we are having this component with utmost importance. I mean, ranking module is playing a huge role nowadays because it has been assumed based on the several year experience that ranking is something which captures the user preference in the first step or in the first position on the search results. So we can have two mechanisms. Either we can provide some criteria on the GUI through which user can apply his ranking order on the received results, or you can have some inbuilt mechanism to rank the results, right? So ranking is something which is there to, list down the results with similar requirement, with similar expectation of users. And then you can, after ranking the results, you can push down the results to the evaluation system, then it goes back to user. So this primarily, describe all the different components placed on within a search system, their basic interaction, right? So any question if you have related to this, we can take. And naturally in the upcoming lectures, probably around up to, so today we are having 6th lecture. So next 10 lectures are there to discuss different conceptual details about these different components. So you can see here, there are 6 computing blocks: text acquisition, then transformation, then indexing, then we have matching, ranking, evaluation. So with respect to these six computing blocks, we will discuss these conceptual details in upcoming 10 or maybe 12 lectures actually, because there are 2 lectures planned for discussing about how to evaluate the performance of this entire system. So performance evaluation is the important aspect. So we will have 2 lectures for that, right? So that's it for today's discussion. And now, if you have anything to raise, you can discuss, because there are many things which are planned, but we have missed initially. Yeah, any question from your side?